So this week we discussed infiltration. We have already covered transmission. And with those two heat loads and heat losses in a house, we are ready to move on and do a heat load calculation. So we said, in layman terms, let's try to give meaning to symbols. Infiltration heat loss is air heat capacity. Makes sense? How much the air can hold of heat. Water also have heat capacity. We'll talk about that when we do hydronic system. It's going to be water. Question.
What do the X's represent?
Multiplication.
Okay.
So air heat capacity multiplied by the amount of air that leaves the room per hour. Make sense? If we have a certain volume in the room, in the house, how many times per hour would that complete amount of air leave the room and comes back? Because this amount of air, we invested some money to heat it, to cool it. If it leaves, we're gonna have to heat the other ones. The volume of the space, that has something to do with it. If it's a small room, it's going to be different than a big room. What is volume? Width, length, and height. And temperature difference. If the air inside is warm at 75 and we're losing that air to the outside, what is the temperature of the air coming inside? Is it 10? Is it 15? It's going to make a difference. So whatever you bring in, you have to heat. So you're losing heat. If you lose cold air to the outside, the hot air will come in and you have to condition that. We put some abbreviation to make it smaller. This is easier to write than to write all this. However, if you think you can forget, you can put it in a card and put the symbols here. I would say this the heat capacity of air, and it's a property, does not change. This is the exchange rate, how much we're exchanging that with the outside per hour. Like in 1 hour, how many times is it going to replace the entire air? This idea makes sense? Let us say this room is 300 cubic feet. In 1 hour, how much are we using? Are we changing the entire room, half the room, a portion of the room per hour? Volume times delta T. So this is in numbers, and we wanted to work this example. I will do this example and I'll give you one to look at. Where do we find this information about infiltration heat rate? If you get your book and look at page 71, I'll spend some time explaining what it means. But I'll do one example first.
I'm sorry, page what?
71. So here, we're asked to calculate the infiltration. So I'll go with the QI is infiltration. What is the, I'll put it in, infiltration rate. Times volume times temperature difference. The infiltration is given as 0.8. The volume, we're going to calculate the volume, 30 times 8 times 50, that's a big room. Temperature difference, 60. Let's fill it out.
Did you say it was? Oh, never mind.
Plug it in the calculator. And this time it's all multiplication. Now there's some kind of differences. So we all know about the order of operation. What takes precedence? Multiplication, right? So we'll do the multiplication first. So we have PEMDAS. parentheses first, exponential, multiplication, division, addition, subtraction. So first we do what's inside the parentheses, 60, 50 times 8 times 30. That is huge. So probably it's a warehouse or a hangar. It's so big, it's so many holes. That's a lot of exchange rate per hour. So that's a lot of heat.
So this is the amount of heat that is leaking out of the house?
Yeah, we're losing this heat.
Okay.
How do you know we're losing heat? Because the inside is 70 and outside is 10. If it's the other way around, you are gaining heat. That's the heat direction. So let's do this example quickly together. I'll give you 5 minutes to work on it. But before you do that, I want to show you where do you find. Everybody has the book and at page 71. So the infiltration rates are all found here in page 71. But what do they mean? This book is rich of information. It has a lot of worked examples and has all the information you need. You just have to read the small font. Every time I discover something new. But I like this book very much. So if we look at the infiltration in here. So we have 3 sections, right? And they're all the same. And this gives you number of air exchange per hour, infiltration factor divided by 0.018. So that's a conversion between the heat air capacity from minute to hour, but they did the math for you. So that's going to be your infiltration rate here. And for this section here, filtration heat loss factor, windows and doors not weather strips and no storm sash. You'll use these factors. Room with windows and doors, one side only. What does that mean?
There's only one side.
With windows on it.
What if there's more than one window on it though?
It doesn't matter. It's given the same factor. Good question. Good question. So let's look at this room, for example. This is inside the house. We have 2 windows on one side, this is completely brick wall. Which factor we're gonna use? This is going to be a room with windows and doors on one side only. This is one side, right? It doesn't matter how many. That's one side. And if we have another window here, which one we're gonna use? 2 sides. You can have 3 sides as well. Sometimes the room will be sticking out. Or have 3 rooms and 3 sides, you can use 3 sides. Entry hall, you have a door coming to the house, you can use this factor. Sunroom, with many windows on 3 sides. Sunrooms are very popular. You go in a sunroom, it's all windows, so you can use a big factor. Again, this is very general rules, came from construction and repetition, so we'll stick with those numbers. The second part here, windows and doors are weather strips and with storm sash. See the factors had reduced and the same terminology.
What do you mean by storm sash? Is that like extra insulation around the window?
Yeah, they have a storm sash in the window inside. And we'll see some pictures of that. And these are the infiltration heat losses if you have no porous wall. Something with a lot of holes in the cabin wall, log wall, brick wall with no insulation, that's what you will use. So let's, this is your infiltration over here. These are the factors. And if we look at, again, if you keep going to page, I don't know, I don't think it's numbered, but these little tables here, which are very, very tiny, because they want to fit the entire house on one sheet. If you look at the first square over here, where we're going to fill our infiltration. Volume. Use volume above grade only. So if half the room is underneath the ground, you do not use that volume. And that also goes for basements. If the basement half sticking out, you only use the upper half. It's going to be your volume here. That's, we all know how to calculate the value.
Yeah.
Okay. Where do you get the factor? Somebody.
Page 71.
71. Plug in the factor. DTD. What is that? Design temperature difference.
Delta.
Delta T. I thought inside. Boom, boom, boom. We get the heat loss. Yeah.
So when you find in the volume of the room, do you measure from drywall to drywall, or do you measure from the stud to the other stud? Because the thickness of the drywall.
Now you go from drywall to drywall.
Okay.
Yeah. Think about the air inside the room, the volume of air and where does it go. If you have a cathedral, that's going to be another thing. So you're going to have to measure the cathedral. And if this is something you're going to do for a while, or interested in, you might want to like read through the book because there's a lot of good worked example. For example, we did something like that before, last week. When you have a sandwich or a wall with many layers, how do you get the resistances? We did that. You guys all did. So you get the resistance for the outside wall, resistance for the wood, resistance for the sheathing. It's all resistances. You add all of them together, it's our total. Then you get your U factor, 1 over U factor. We did that already, so we're aware of it. And what do we have here? We have a big list of all the resistances for most common construction material.
What page is that?
This is page 50. And also your residential heat book has a lot of material. Let me see which book.
Yeah.
So whatever you need for heat loss is in the heat loss book, but there are some material in here that you can use. And I think it's in the back end, yeah. If you look at the end of the book, at the appendix, there are some material here. You can get the hot insulation, R values, and if you find new material that it's not in the book, what are you gonna do? Google. You can either Google it or you can call the manufacturer, and they are obligated to give you the R factor. I think it's by law now, if you buy insulation or any material, it should give you the R factor because you have to consider that with the heat loss. These things are becoming the law, and I have a student actually from the night class who was saying there's a lot of companies now looking for people who can do heat load calculation. So I'm here for you to help you understand how to do it. If you do this, it's a very, very good skill. The pay for these jobs are very handsome, and if you understand how it's done, not a lot of people know. But you're here, you're putting up with this class and this material and all this math, you're learning it, so make the best out of it. You're already here, might as well learn it and get this skill. If you get the certificate, that will also be something nice to put in your resume and also go an interview and show that you have a certificate. Question?
Another position for heat loss is counter guys at the warehouse or the supply house. So my manager, he's been doing a bunch of heat losses lately for contractors.
Yeah. So and most of air conditioning and heating companies, they need somebody to do the heat load before they can install. Why? You go to a house and they have 6-ton AC. Maybe you do not need 6 ton. You need somebody to verify that before we install something that's not large enough and doesn't have to give enough heat. So I'll give you 5 minutes. Let's try this. This example. Room with one outside window, with storm sash and weather strip. It's kept at 75 degrees from the outside and 10 degrees from the inside. The room dimensions is 15 feet long, 12 feet wide, and ceiling height of 8. What would be the infiltration heat loss? Let's take 5 minutes and do it, see what you do.
But I'm sorry. How do you sign up for the license for that?
When you're ready, let me know. Email me and I'll.
Okay, so don't we have to find the
Okay.
what was the math we were doing with the windows the other day? Don't we have to do that?
This is infiltration.
Oh, this is air leaking out.
I want the infiltration heat loss. 5 minutes. Can you pause?
No, no.
Right.
Yeah, I wasn't even sure if formula to use. You use this formula for that? So you gotta have it for glass. Right. One side. Same.
Sure, the answer should be around 1,100 or something. Oh, I haven't seen nothing. I gotta tell you, you haven't seen nothing.
I fire anyone who wants.
You're in school, man. You signed up for this. You signed up for this. You need it. I'm not giving you anything. When you graduate and you get a job, you'll see what difference does it make. I know people who graduate.
This is gonna be about.
Yeah, that's correct. Yeah. Okay, let's do it together now and see what do we got. Attention. Last. Equation is the same, it's not going to change. What is the infiltration rate? 0.012. Everybody got something else? So from the book, 0.012, and I'll show you where did it come from. Page 71. So if we look here, I did say it's a window with one side only, and it is weather stripped with storm slash, so 0.12. Does everybody understand where I got the 0.012? If not, please raise your hand. Okay. What is the volume?
1440.
15
No.
times 12 times 8 times temperature difference, which is 75 minus 10. I plug in the number and this is the number. I get in my calculator 1123.2 BTU per hour. If you got a different answer, raise your hand. So probably you picked the wrong factor, or maybe you messed up something in the volume. But if you write everything out in the quiz or in the homework, you'll get partial. But the rest is just chug and plug, as they say. Any question about this? And this is the part for infiltration. With this, we're done with infiltration. And we know how to do transmission. We did a few examples in that. And that should be it. Now, that's it for this week.